We start off with the chapter statistics from section A. So this is the chapter which is compulsory for each and every single one of you, and we have quite a reduced syllabus from the last, means from the actual thing. So we are not going to cover a lot of things. So we will be covering only those topics which are there pertaining to the reduced syllabus. So in this class we are discussing the whole chapter, of course, and the topics which we have is mean deviation about mean and standard deviation and variance. Now, mean deviation about mean, it is specific to mention that we have only one of them, that is mean deviation about mean, but not mean deviation about median. So mean deviation can be calculated about mean as well as about median. So we have only the mean. So now to begin with, let us go through some of those things which we already know, which we have already done, or something which we have been doing right from our first days from when we started doing statistics from your junior classes. So let us understand what are the types of data that we come across. So the first one is the discrete data. Discrete data means when the data values are listed. Data values are listed in the sense, say for example, you are given the data like 7, 2, 1, 3 and so on, like this. If the data values are given like this, then this is called a discrete set of data. And then if the same thing is grouped under, or if this is clubbed together and written in a frequency table, then we call that as the ungrouped data. Fine. Now ungrouped data and discrete data are almost the same thing. It is like the flip side of the coin. It matters how you are representing. So if there are huge number of discrete data such that there are repetitions, then if we list them down by using the tally mark table, then that table is called the table for ungrouped data. And then finally we have grouped data. Grouped data is whenever I have the data given in the form of groups which are called as class. So instead of giving the frequencies for each and every single individual data value, if the frequencies are given for a class of data values, then it is called a grouped data. So we will be discussing the formulas for mean deviation, standard deviation for all these three kinds of data. So to begin with, mean of the data. Now this is something which you have already done in your junior classes, nothing new, but let us revisit the whole thing. Now if you have a discrete set of data, say something like this, x1, x2, xn, there are n data values, then the mean is given by x bar. X bar is the notation which we use, or in some cases we use mu as well, and that is given by x1 plus x2 plus till xn by n. So it is like the average, taking the average of all the data values. Then we have ungrouped data. Ungrouped data set looks something like this. If the data values are given, individual data values are given and their corresponding frequencies are given, then the mean is calculated by the formula summation of fi xi divided by summation of fi. Right? These are certain things which you already know. And then finally, the same thing we do for group data as well. Now in case of group data, if we have the class intervals and frequencies given like this, L1, U1, L2, U2, these are all the class limits, lower limits, upper limits, like that, then we can calculate using the same method in the sense we can use the formula x bar is equals to summation of fi xi by summation fi, but here this xi's are called the class marks. How to calculate the class marks? Class marks are basically the average of the sum of the lower limits and the upper limits. So therefore, this is the general formula for finding mean. Doesn't matter what kind of data it is given. If there is frequency, then you can always use this formula. But there are other formulas too as well, the formulas which help us calculating the mean even faster, and those formulas are called, one of them is called the assumed mean method, the other one is called the step deviation method. So let us just see into it. So basically these are the class marks which I was talking about. And what is the assumed mean method? The assumed mean method is considering any one particular value of xi, this a is called the assumed mean. This is called the assumed mean. So this one particular value, it is something which you assume to be the mean. So from the list of all the xi's, from the list of all the class marks, you select any one value to be the assumed mean, and then you calculate the di's. Now how to calculate the di's? You subtract that value from all the xi's, and then you proceed to find this value, that is summation of fi di by summation of fi, by calculating those respective columns, and then adding it back with that assumed mean, you get your mean, right? We have already done this. Then the next one, it is the step deviation method. Step deviation method is almost the same thing. Now here I have one small issue. Mind you, this UI and this UI are not the same UIs. I should have used a different nomenclature for this, but I now realize that I have made this one mistake. Not a mistake, but if you understand what they stand for, then I think you won't be having any problem. These UIs are basically representing the upper limit of the class intervals, but this UI is representing a new variable. I hope that part is clear. Okay, so now the mean is calculated the same way. Here this a is the assumed mean, which we assume from the list of all xi's, and this h is the scale factor. Scaling factor means if there is a common factor which we can divide out, so that factor is h, right? So these are different methods which help us doing the calculation a little bit easier. Now we will be seeing how we will be using this in the problem, so it will become more clear to you. Now let us move to the main topic, that is, this is what we have in class 11, that is mean deviation of data. Now before we go into the idea or the formula of mean deviation, let us understand what mean deviation actually gives you. Say for example, you have the data x1, x2, like this up till xn, and you find the mean of all these data, that is x bar. Now mean deviation, the word deviation, by the word deviation it means that how much the values are deviated, how much values are different from the given, from the mean. So what we need to do, we need to find the difference between all these values and find their average. So if we do so, whatever the value we get, we call that as the mean deviation. Now it means that if the deviation, doesn't matter if it is mean or anything, always remember when I'm trying to calculate deviation, deviation means it is giving us the idea that how much dispersed the data is. That if deviation is more, the value of the deviation is more, it means that our collection of data is not accurate. If the deviation is less, then obviously our data is more accurate or more authentic. So therefore, this deviation helps us to understand that if we have too much of error in our collection of data or not. To calculate mean deviation, what we need to do, say we have a discrete set of data. Discrete set of data means like x1, x2 up till xn, like that the data is given. Then the mean deviation is given by, mean deviation is equals to summation of mod of xi minus x bar by n. N is the total number of observation. Now, obviously, in this formula, I have x bar, which means that I have to calculate the mean first, then again put it back in the formula to find the mean deviation. Fine. And again, if we have frequency distributions, frequency distribution means if there are frequencies given, in that case the same formula turns into summation of fi into mod of xi minus x bar by summation of fi. Fine. Next, so let us understand the whole thing by few problems. So the first problem is, find the mean deviation about mean of the following data. So the data is given, I have to find the mean deviation about the mean. So for that, first I need to find out the mean. So mean is basically add them up, divide by the number of data given, and that is equals to this 10. Now let us put it in this formula, that is the formula for mean deviation, that is summation of mod of xi minus x bar by n. So basically the formula turns out to be something like this. Our mean has come out to be 10. Each and every single data value here we have 4, 7, 8, 9 and so on. So it will be mod of 4 minus 10, then mod of 7 minus 10 and so on till mod of 17 minus 10. And after calculating all these values, we divide and we get the answer to be 3. So our mean deviation is 3. Fine. Now let us move to the second problem, problem number 2. Similar problem, find mean deviation about mean of the following data. Now here in this case, I am given a frequency distribution of an ungrouped data. I am given the data values and their frequencies, and I have to find the mean deviation. Now whenever I am given in a table format, I must make the whole calculation in table format. So let us prepare one table. So the table looks something like this. So I have to make this 5 columns. One is xi, that is all the data values, then the frequencies, then the column of fi xi, the product, then the column of calculating mod of xi minus x bar, and then finally calculating the column of fi into xi minus x bar. Now see here, there is one important thing. I need to first calculate x bar. If I don't calculate x bar, I won't be able to finish off these two columns. To finish off these two columns, I need to calculate x bar. So let us first calculate x bar. Now what is x bar? It is basically summation of fi xi divided by summation of fi. So this is what x bar is. X bar, that is the mean of the given sample. Now once we know that the mean is 14, now what we can do, we can calculate the corresponding xi minus x bar. So see, 5 minus 14, so if I take this value 5 minus 14, so that is 9. Obviously taken modulus, it is 9. Then 10 minus 14 is 4, 15 minus 14 1, 20 minus 14 6, and 25 minus 14 is 11. So therefore let us just put those values. Right. Now the rest of the work is easy. Multiply with the frequency and write the table and find the sum. So this is what you get. Just check on the calculation. I hope there is nothing wrong. Now once we have the final table where we have already calculated this value, that is summation of fi xi minus x bar, that is 158 in this case. So therefore the mean deviation comes out to be summation of fi into xi minus x bar by summation of fi, and that is 6.32. Fine. I hope the idea is clear. Now let us take another example, but in this case let us take grouped data. So same concept, we need to find the mean deviation about mean, but for a group data like this. So once again we need to make a table. So here there will be 6 columns for the matter of fact, or I have used step deviation method, so I have got a few more columns. So that is ci, xi, fi, then ui, fi ui, that will help me calculate the mean, and then again these 2 columns are obviously there. These 2 are going to help me to calculate the mean deviation. Now you can ask me, why did I use this? Now there was no hard and fast rule until and unless it is mentioned in the question that you have to use step deviation method or you have to use assumed mean method, then you have to follow it. But otherwise, if nothing is mentioned, you are free to use any method you want. But always remember that using step deviation or assumed mean method helps you to make your calculation easier. Now you may say that you have calculator, so it really doesn't make any difference, but I'll tell you that it makes a lot of difference. Why? Because even when you are using the calculator, when you are just putting the values in the calculator, you have to type more in the calculator. You have to spend a lot of time with that calculator for inserting these big values. But if you just scale it down using this step deviation method, you see you are working with -3, -2, 1, 0. So all these calculation you can do mentally, and always remember that your mental calculation is faster than your calculator, because no calculator has been invented yet which can do the calculation mentally. If you are mentally sound enough to do the calculation, that is one assumption made, obviously. So your mental calculation will be always faster than any calculator. So therefore, remember, use your calculator, no problem, but use it well. So not always that using calculator helps you, because you will be spending too much time with the calculator as well. So keep that in mind. Now, so let me calculate the mean first. So mean will be, now the formula for finding mean in the step deviation method, if you remember, let me just write it once again. So x bar, or let me use a different color. The color is just not, let me use white. Okay. So x bar is basically equals to a plus summation of fi ui by summation of fi into h. Now what is a? So here I have considered 350 to be a. I have considered 350 to be my a. So this is your a. And what is h? H is 100. 100 is the scaling factor. So you see 50 minus 350 is 300. Minus 300 divided by 100, that gives you -3. Similarly, it is -2, -1, 0, 1, 2, 3, 4. So understood how to calculate the UIs? You should know this, but still I am explaining. And then again, you multiply it with corresponding frequencies and you get this column, and this is the sum. So this is your summation fi ui. And this is the total sum of the frequency, so this is your summation of fi. Fine. So now put all these values in the formula and calculate. So this is your mean. Fine. Now I need this mean to calculate this table, this column and this column. So let us calculate. So I just did the calculation right there. So once you get the mean, then mod of xi minus x bar, so 358 minus 50, that is 308, 350 minus 150, that is 208, and so on. So this gives you your xi minus x bar column, and then fi into xi minus x bar column. Just to do the corresponding calculation, this is what the value you get. Then your mean deviation will be summation of fi in summation this column, the last one, it will be the last column divided by this summation of fi, and this is your value. Fine. Let us move to the next topic, that is standard deviation. Now standard deviation, now you may ask the same question, that what is the use of standard deviation? Now standard deviation gives us more precise value of the deviation. Now mean deviation is giving us a rough idea of how much dispersed the data is. Standard deviation is giving me more accurate data of how much dispersed the whole data is. So if standard deviation values are higher, you know that your data is really bad, means your collection of data is not good. If standard deviation is low, then you should know that your data is accurate enough. Now before we move on to the idea of standard deviation, we have an intermediate concept which we call as the variance. Now variance is denoted by var x, var inside bracket x, or small sigma square, and is defined by sigma square, that is equals to summation of xi minus x bar whole square by n. Now if anyone who is going to study statistics in your future, in your college, then you will be seeing that variance is called as the expectation of order 2, and mean deviation is called, or rather mean is called, the expectation of order 1. So let us not go in details of that, but this is just a heads up. Now for frequency distribution, if you have a frequency distribution, you will have sigma square, the same formula, just that there will be frequency involved in the formula, almost same as mean deviation, right? And then what is standard deviation? Standard deviation is nothing but it is the square root of the variance. So whatever you calculate as the variance, if you take the square root of it, then you get the standard deviation. Fine. And also pretty much so that the standard deviation is denoted by sigma. Fine. Then there are some direct formulas for calculating standard deviation. So if we don't want to calculate the variance and then we go on calculating standard deviation, if the question is asking us about calculating standard deviation only, then we can definitely use this direct formula, that is sigma is equals to 1 by n in under root n into summation of fi xi square minus square of summation of fi xi. Right? Now what is capital N? Capital N is basically summation of fi. Summation of fi is basically capital N, that is the total number of observation. Now there is a shortcut method, or which is called also the step deviation method. Now this is the step deviation method of finding standard deviation, and the step deviation method looks something like this. So basically when I'm changing the variable from xi to ui, where a is the assumed mean, this is your assumed mean, and h is your scaling factor, that is this is exactly what you have used in case of finding the mean using standard deviation. So same thing. Then the formula is all the same, almost all the same as this one, but there is one small h multiplied along with it. So just remember this one formula, and just remember that in case of shortcut method you will be having one small h multiplied with it. So if you remember it that way, then it will be easier for you, because remember, statistics is all about the formulas. Now you are not doing any higher studies that where you have to know from where the formula comes and how to make use of it. You just remember the formula and use it. That's what we have for your level. So if you just forget a little bit of the formula, if you just mess up the formula, then your whole problem will be wrong. Fine. Now let us take few problems and solve. So question number 4, find the mean and the variance of the following. So you are given the data, you have to calculate the mean. So for the mean, simple, add up, divide, you get the mean. The mean is coming out to be 9. Then variance, so once you have the mean, then for the variance, what you need to do, you need to subtract the mean from each and every single data value, take the square of it, and then add and divide. So basically this is your mean. So 6 minus 9 whole square, 7 minus 9 whole square, 10 minus 9 whole square, and so on. So if you just calculate and divide, you get the variance as 9.25. If they would have asked you to find the standard deviation, you just would have taken the square root of this 9.25. It would have given you the standard deviation. Now let us move to next problem, number 5. Find the mean and variance of the following data. The data is given this. Again, this is an ungrouped data. Now in case of ungrouped data or not, if it is grouped also, the formula is all the same. So here I have to make this table. So I have the table of FI, XI, FI, FI, XI. Then what we did for mean deviation, we are going to do the same here. We have to first find the mean, then put it back in this table to calculate these 3 columns here, this 1, 2, and 3. So here let us first calculate the mean. So we have already calculated this this particular column. So we calculated this column. So therefore the mean is summation of FI XI by summation of FI, that is 760 divided by 40, and that is 19. Now once we know that it is 19, so now our job will be to calculate this mod of xi minus x bar. So it is, if you just see, 6 minus 19 is 13, I mean minus 13, modulus taken, it will be 13. 10 minus 19, 9, 14 minus 19, 5, 18 minus 19, 1, and so on. Then square it up. If you square it up, this is what you get: 169, 81, 25, 1, 25, 81, 121. Then multiply this with the frequencies, so it will be a bit bigger calculation. Once you get this table, find what is summation of FI XI minus x bar whole square. Then what is the formula for variance? Variance is summation of FI into XI minus x bar whole square by summation of FI. Put it, calculate, you have your answer. So your answer is 43.4. Fine. Okay. Now let us move to the last problem, problem number 6. Here in this question we have find the mean and the standard deviation of the following data. So now see this question is asking you to calculate mean and standard deviation. Now it is not asking you to calculate variance. So in this case what we are going to do, we are going to use the direct formula for finding the standard deviation. We are not going to go through the step where we have to first find the variance and then we have to find the standard deviation. So let us draw the table. Now I have done the table all together in one go, so I haven't shown you the different steps. I'm explaining it to you. Now whenever I'm trying to make use of the direct formula for finding standard deviation, I will make these few columns. So I require the column of FI XI, I require the column of XI square, I require the column of FI XI square. right? Then there are certain things I need to calculate, that is the total frequency, that is your capital N. Then I need to calculate summation of fi xi, that is add up the column of fi xi. So this is the second thing I need. And the third thing I need is summation of fi xi square, right? Fine. Then the question is asking me to calculate the mean and the standard deviation. So let me first calculate the mean. So mean is basically this innocent formula, summation of fi xi by summation of fi, and that is your 1350 divided by 50, 27. Fine. And then standard deviation, this huge formula, 1 by n root over of n into summation of fi xi square minus summation of fi xi whole square. So you already have all the values at hand. Put the values, calculate, and after putting the value and calculating, your standard deviation is 11.49. Obviously I have rounded it up. You can leave it up to 3 decimal places, but it's better to leave it rounding it off to 2 decimal places. Fine. Now I will do what? I will show you the same problem solved in the shortcut method, that is the step deviation method of finding standard deviation. Why? Because you see, doesn't matter what, whenever I am trying to calculate the step deviation, the standard deviation, at the end, this particular table, you see, the values are becoming really large, and there can so happen that if these values are given such and these values are given such, that this particular values may become really big. So in that case, we need to make use of the step deviation or the shortcut method to reduce our calculation. Now remember that once again, you have the calculator, you have the liberty to do it using the calculator, but remember this, inserting all these big values and then calculating may somehow, if you put a wrong digit, you may come up with wrong answers. And always remember, statistics question, they are easy to solve, but they are very easy to do mistakes as well, because in statistics questions, so many numbers are involved, so many digits to take care of, so you may make mistake. So you are prone to make mistake in case of statistics. So therefore, let us see how to solve the same problem using step deviation method. So let us move to the same part. So I am just going to show you the table, the same table. Now you see how simpler the table looks. You can calculate the table without even using calculator as well. So you know this, that this table, maybe you have 1 or 2 column extra, but the calculation is much simpler than the previous one. So what I have done nothing extra, just I have calculated this part, that is the UI. Now what I have done this, I have considered this 25 to be the assumed mean, that is my A, and the scaling factor, that is H, to be 10. I have considered A as 25 and H to be 10, and then I have calculated the UI column. So all these values, you see how simpler these values are, -2, -1, 0, 1 and 2. So then we have our frequencies, then multiply frequency with the new variable. So 5 into -2 -10, -1 into 8 -8, 0 into 15 0, 1 into 16 16, 2 into 6 12. Add it up. So add up all the frequencies, this is your total observation. Add up FI UI, this is your this column is done. Now you see, till now no calculator required. UI square, obviously 4 1 0 1 2 4, and then multiplied with FI, so 28 16 24. So you add up, you get 68. So see, you can finish off this table much faster than the previous table, even using calculator. So using calculator is absolutely immaterial if you use this method. Now what we need to do, we need to calculate the mean and the standard deviation. So for mean, this will become the formula A plus summation of FI UI by summation of FI into H. Put all the values and you calculate. Again, you can see you can do the calculation even without using calculator. Done. And then For the standard deviation, it will be h by capital N under root capital N into summation of fi ui square minus summation fi ui whole square. And you already have all the values at hand. Put the values, calculate, the value becomes 11.49. So maybe you require to use calculator here just to calculate the square root. So that's the only place you require it. Fine. So that's it. That is our chapter, simple chapter. So this is the first chapter covered from your third CET syllabus, rather the second term for CET syllabus. And we will come back once again the next day, the very next class we have with our next chapter. And as always, if you have doubts, please clarify. Thank you.